Our final speaker of the session is Dr. Desiree LaBeaud. She is a professor of pediatrics in the Division of Infectious Diseases, as well as a senior fellow at the Woods Institute for the Environment at Stanford University. And she will be talking to us today about the intersections of respiratory and infectious diseases.
Hi, thank you so much for the opportunity to talk with you today. And I'm going to try to interweave respiratory disease, infectious disease, and the plastic pollution crisis. So stay tuned for that. So we're here today talking about the effects of climate change on health, and we're focused, of course, on the respiratory system. We've heard a lot about wildfires, the dust storms, the pollen, air pollution, and I'm an infectious disease specialist. And so I care a lot about infectious disease. And of course, as we've heard in prior talks, there's going to be impacts on the vector-borne diseases that I study, but also food and waterborne disease. And so I just wanted to start off this talk by just talking about the intersection of respiratory and infectious disease. So what is going to happen with infectious disease and climate change and respiratory infectious disease? Well, climate alterations may directly or indirectly affect the incidence and severity of respiratory infections, because we can affect the host, our immune systems that we've talked about a little bit, but then also the vectors that sometimes vector infectious disease and bring them close to us. Changes in temperature, precipitation, relative humidity, and air pollution definitely influence the pathogens, the viruses, and transmission, right? And that can definitely compound epidemics. And also, climate change shifts all of the habitats, wildlife, the crops, the livestock, humans, and all these different vectors that we come in contact with. So that's mediating a lot of the risk, right? And the exposure that we have to these pathogens. So first, an example of direct, and you'll hear more about COXI later with Dr. Chow, but when I think of direct impacts of climate change and respiratory infectious disease, I think of COXI, right? COXI is endemic to the Southwest US. Humans are exposed when they inhale the fungal spores of either Coccidioides immitis or Potidaceae. And human disease is usually characterized by pneumonia. Often it can be asymptomatic, but if you're going to get COXI disease, you get pneumonia, but it can also disseminate. And I see those patients in the hospital with bone infections, brain infections, and so forth. And cases are clearly a direct result of human exposure to the environment because we're inhaling these spores, right? And therefore clearly connected with climate change. So what's going to happen with COXI as the world warms? Well, the territory of COXI is growing, and it's really driven by these patterns in climate. So in order for the fungus to really grow, it needs it to be wet, right? So if you have a lot of rainfall, you have wet years, and then that followed by a dry year when they sporulate, and then the winds and the dryness allows the dirt to come into the air with all of these COXI spores. So you can see that these patterns in climate actually mediate our exposure to the infectious agent. And climate projections for the Western US indicate, as we've seen in many, many slides before, that temperatures are going to increase, right? And precipitation patterns might shift, which is clearly going to alter COXI disease dynamics. And in a high warming scenario, models show us by 2100, the area of COXI endemicity in the US is going to double. Affected states are going to go from 12 to 17, and cases are going to increase by 50%. The rest of my talk, I'm going to talk about some indirect climate interactions with pulmonary infectious disease. And I wanted to start with hantavirus, actually, because hanta causes hantavirus pulmonary syndrome, right? Flash pulmonary edema. And it's vectored by this cute little guy here, the deer mouse. And these populations of deer mice, again, they need to eat, right? So when vegetation is abundant after heavy rains, their populations grow. And so climate actually affects the food and water supply for these vectors, the deer mice, and that again affects the distribution and the abundance of these mice, which then again mediates our risk and exposure to the agent. Okay, so I've talked a little bit about direct pulmonary infectious diseases, COXI, hantavirus. You're going to hear more about fungal infections from floods later. Plague is another one. And then there's seasonality shifts. We don't understand why a lot of infectious diseases are actually seasonal, right? But we know we have our respiratory virus seasons. Often they're in the fall or the winter. And clearly with shifting climates, that may also shift those things. And then you can imagine the overlapping circles, right? With what else is going on during those seasons and what might change. And this brings me to, this has been alluded to, but we are highly interconnected in the web of life, right? Climate change is shifting all of the natural systems, and human health is inextricably linked to the health of the plants, the animals, and the ecosystems on our little tiny blue ball. The range, life cycle, growing pattern, disease dynamics of many living organisms are affected by these climate these changing climate conditions, and changes in climate really influence, again, the habitat suitability, reproductive rate for host, vector, and pathogens of lots of the infections that I really care about. And so we have to, when we think about climate and we think about climate impacts on health, we really need to take a One Health approach, a planetary health approach. So I just wanted to bring up the fact that, okay, we're talking about climate change, global warming, and burning of fossil fuels definitely leads to this increased temperature, which leads to sea level rise and ice mass loss. And there's our characteristic megafauna of climate change, right? The polar bear on its shrinking ice cap. But climate also alters mosquito habitats, right? And I am an arbovirologist, so I think a lot about this. There's extreme weather events, warming temperatures that all have an impact, right? So don't just think about that polar bear. When you think of climate change, I want you to think of swarms of mosquitoes, okay, after this talk. And also, there's shifts in flower and plant blooming, which we've talked about a little bit today already with the pollen talks. But I want to tell another story, a climate change story, actually the pandemic we've all lived through. Does everybody here understand how COVID is totally intricately linked to climate change? It all happens with these cute guys here. Turns out with the flower and the plant blooming shifts, right? The animals are not, and bats in particular, are not getting their food when they're expecting, okay? So there's no plants for them to eat in the wintertime. Poor starving little bats. So what do? They go into the agricultural areas to feed. What's in the agriculture area? Food and a lot of other species where the viruses they're excreting can commingle with all of the other species and ta-da, give us new pandemics, right? And this is what happened with COVID. And it's also important to know that a starving bat is a sickly bat, and they excrete and secrete a lot more virus than a healthy bat that gets to eat its flowers on time, right? Or its fruit or whatever. And so again, everything that's happening to us, all the bad things can be related to climate change, okay? And this has come up, but when you talk about climate change, you really have to talk about health inequities, right? You know, the increasing CO2 levels, the rising sea levels, the extreme weather events, the rising temperatures are affecting marginalized populations who are already at risk for all the other badness more, right? So we talked about air pollution and increasing allergens, extreme heat, all of this is mediated by inequity, right? Severe weather events, which environmental degradation that can lead to forced migration, degraded living conditions, and just baseline social inequities, water and food impacts, supply impacts, actually nutrition impacts, which we've kind of highlighted a bit today, water quality impacts, and then changes in vector ecology. So I'm just going to spend a few minutes talking about this bad girl. So this is Aedes aegypti, and she is an efficient spreader of a lot of mosquito-borne viral infections like dengue, chikungunya, Zika, yellow fever, which are the infections I study. And just to remind everybody in the room that mosquitoes are the most deadly animals in the world, right? And it's not just Aedes aegypti, right? There's lots of mosquitoes that like to feed on us. These three species or groups in particular, the Culex, the Aedes, and the Anopheles groups of mosquitoes really give us a lot of pathogens, and these are the ones that are killing us. And they're really impacted by climate events, right? Mosquito-borne diseases are on the rise. Culex loves stagnant water, so floods and flooding. It likes to breed in stinky water, spreads West Nile, which is our most important arbovirus here in the US. Aedes, like I showed in the last picture, really likes it hot. And she is you can have outbursts of Aedes with either droughts or floods because she's a container breeder mosquito. And so when people don't have safe, reliable access to clean water, they often store water in these uncovered containers, which then can breed these mosquitoes. Floods can also cause an increase in abundance for Aedes, and she spreads dengue and other infections. And then Anopheles, right? The mosquito vector for malaria, where warmer temperatures can lead to increased parasite development, quicker parasite development, and just more mosquito abundance. So because mosquitoes are ectotherms, right? Everybody thinks, oh yeah, you see it on every slide, vector-borne diseases on the rise, right? But it's not just a linear model, right? It's not as the temperature gets warmer, they're just gonna be more and more vector-borne diseases everywhere. It turns out that it's a lot like Goldilocks, right? Mosquito physiology, there's actually temperature optima for all of the mosquito traits that are dependent on temperature. And there's the perfect temperature for that trait to happen, and it can be too cold or actually too hot for it to happen, right? And it turns out that every mosquito vector has its own favorite temperature by which it likes to spread diseases to humans. And so when you think about vector-borne diseases in a warming world with climate change, if you just think about the warming aspect, it's not that everything's going to get worse, but it's quite nuanced, right? And we've done some work with Erin Mordecai, who's a math modeler and biologist here at Stanford, and just showing that it's not that everything's going to get worse, right? It's just that it's nuanced and there's going to be shifts in where these vector-borne diseases are. And if you look at these diagrams here, you can see there's a shift of malaria across sub-Saharan Africa. And then dengue is just getting worse and worse, right? Because again, the malaria, or excuse me, the dengue vector Aedes aegypti does like it hot. So to bring this back to existing inequities in vector-borne diseases, because we're really environmental health specialists, we're very proximate to a lot of these inequities. I'm going to talk today about solid waste because it turns out those container breeding Aedes mosquitoes that spread dengue and chick and Zika in the world actually prefer to breed in our man-made containers in trash. So I'm going to spend a little time talking about the plastic pollution crisis. The built environment, we've heard about it a little bit, but that's very important, right? Because structures actually protect us and can put us at risk for being exposed to pollutants in the air, like we've been talking about, but also vector-borne diseases. Governance is incredibly important, right? Sanitation, public education, control programs, and so forth. And that can be limited sometimes in highly resourced or lowly resourced nations. And then finally, structural factors, right, which are underpinning everything. I don't even call things social determinants of health anymore. I call them structural determinants of health, because underneath the social is always structural racism and violence, health access issues, poverty. So today I want to spend just a few minutes talking about this. So I work in Kenya. I've been working in Kenya for 20 years. And this is some plastic trash there. This is present in many, many parts of the world. Now, you may be thinking, hey, I'm at a pulmonary conference. What does this have to do with pulmonary disease, right? Well, it turns out that with our increasing culture of consumption and the increased plastic production, a lot of plastic is getting burned in the world. In fact, 600 million tons of solid waste, a lot of which is plastic, is openly burned annually. Where I work in sub-Saharan Africa, 75% of waste is burned. And this, of course, leads to poor air quality, air pollution issues, particulate matter. They're like mini wildfires, right? If you can imagine, every day. And it's a contributor to the millions who die annually from poor air quality. So all that trash is leading to a lot of mosquitoes and poor air quality, right? So I've been working in Kenya in 4 sites for some years. And what we've been doing is measuring febrile illness in children, and particularly trying to rule in vector-borne diseases. We've also been measuring climate data annually and trapping mosquito vectors at all their life stages. And so with these sort of longitudinal studies, we get a lot of information, and we've definitely shown like extremes of weather, droughts, floods, and so forth, increase the vector abundance and then disease risk in our communities. But today I really want to talk to you about trash also. So it turns out that plastic trash is collecting water and making really ideal breeding grounds for Aedes aegypti. And so in our studies, we've collected many, many tens of thousands of mosquito samples and from water in these containers, and actually found that trash is actually the #1 spot where all these mosquitoes are breeding in our communities in Kenya. And unfortunately, all of this trash is laying very close to human dwellings. So humans are being exposed to these mosquito-borne diseases where 50% of the community is exposed. So we've done a lot of intervention work. First you realize that you have this great burden of disease, and then you need to do something about it. And so, we worked with community members, school kids as agents of change. We've done cleanups and tree planting to try to deal with this issue. We took some school kids, about 250 school kids who picked up waste for about a month, picked up over 17,000 plastic containers, over a ton of waste. And we repurposed it as much as we could. We grew 4,000 trees like in their homesteads and in their schools. But we were left with a ton of plastic waste, and there's no formal recycling in Kenya. So our choices were burn it, bury it. So luckily for all of you, of course, we buried it, but who can feel good about burying a ton of plastic, right? And this brings me to the plastic pollution crisis. So this isn't just happening in Kenya, right? This is a worldwide problem where plastics and solid waste in general is poorly managed. And, the population is growing, right? We saw those numbers, billions of people, right? And so not only are there more of us, but we keep using more and more plastic. And we know plastics don't degrade, and more than 60% of the world's solid waste remains uncollected. And, we put everything in the blue recycle bin, but it's a lie, right? Less than 9% of anything actually gets recycled, right? So it's all ending up in dumps, poisoning our oceans, poisoning our land, and poisoning our air. And I like to remind people, plastic, it's like, that's just in some of our lifetime, right? You think it's been there forever, but it's really a recent invention. And it's an exponential problem. And it affects a lot of different sectors: the environment, tourism, the economy, and of course, health, which is what we're mainly concerned with here today. So I already talked about the fact that all this plastic laying around breeds mosquitoes that are horrible vectors for important human health pathogens, and that a lot of it gets burned. And so it's definitely affecting our pulmonary systems and our air. But they're also toxic pollutants, right? So microplastics really attract hydrophobic pollutants, and we ingest them, right? And as we heard about with microplastics, of course, we don't even know what microplastics are doing, but we know they're in us everywhere. We're ingesting them in our water, our salt, our food all the time. And so it can't be a good thing, right? And then finally, food security. Of course, plastic is choking our oceans, leading to decreases in biodiversity and really threatening our marine food chains, where most of the world actually depends on a coast for their food. So I am an optimist, though, right? And I see a lot of opportunity here. Because if uncollected trash increases all this disease, then cleaning it up could reduce disease. And so, reducing, recycling, and reusing solid waste, particularly where I'm working in Kenya, is quite minimal. So there's a huge area there to scale up. And this could provide jobs and livelihoods, economic growth, and there are some models, right? There are other models that we might be able to use. And so what we really want to do is create a circular economy for plastic waste, where we collect trash, we give it a purpose, we sell it, we reuse it, we reinvest those profits to pick up more, all with the point of decreasing vector-borne diseases, improving the health of the community, the health of the environment, and decreasing air pollution, because it won't be burned. And so we had one project where we created a business incubator program for yard shop operators and train them and improve their business skills and their connections with government, and train them on health, safety, and waste sorting practices. And this led to a significant increase in the amount of plastic waste traded, which was really important because it means it's getting off the street, where it's breeding infections and actually getting burned. And we really created this strong peer network and significant reductions in the vector breeding here in Kenya. But there was a lot more action that needed to be done, right? We needed a lot more community awareness, reducing stigma because people don't want to work with trash because it's dirty. We wanted to improve the waste infrastructure, create a market for second-use products, work with our policymakers to really enforce all of the incredible environmental health policies that actually currently exist in Kenya, but just aren't being enforced, and then really create and cultivate this recycling culture, right? And so what we actually ended up doing was we launched a nonprofit called the Health and Environmental Research Institute Kenya on the beautiful south coast of Kenya. If any of you have not been there, I highly recommend you go. And this is a perfect place to do this work because the ocean is right there. So you can see the plastic choking the ocean, you see it burning up in the air, and then all the mosquitoes that are being bred from it, right? And so our community business organization here, our nonprofit, is actually led by local, everyone in the CBO is Kenyan. And what we're trying to do here is really inspire community education, new research, policy change, and grassroots activism in these environmental health issues. And we're tackling the plastic pollution crisis and just the waste crisis in general to start with, by building education, awareness, and active community engagement, empowering communities to change cultural norms, destigmatizing trash collection, and really stopping the burning of waste. And we're hoping to really create this really functional network of key stakeholders to create jobs, decrease mosquito-borne and trash-related health risks, and then just improve the trajectories of health for our communities and our planets. And again, our dream here is that waste becomes so valuable, right? Because it's in this circular economy that it just never gets burned. Why would you want to burn up your money? No one would do that, right? And so this is the kind of the vision that we have. And just to kind of build awareness, we've been using art as a medium to really build public awareness and buy-in and start dialogue about these issues that affect all of us. And so we worked with a famous artist named Jean Shin. I got funded by the Stanford Denning Visiting Artist Fund to work with Jean and really upcycle plastic waste through art, right? And this art sculpture, which is called Sea Change, is made up of 7,000 single-use plastic water bottles. It sits in the middle of town in Diani, Kenya, where we're working, where our nonprofit is, and where I've been doing research for about 20 years. And it was unveiled on Earth Day. And the point is, there's a lot here, but there's no safe, reliable access to water, which is why all those water bottles exist in the first place. That's one problem. But then, it's a coastal city, and clearly the ocean is being majorly affected by this plastic pollution crisis. And then we have an art installation here. So we worked with Jean to actually build an art installation at Stanford. It's just right there in BMI. If you guys haven't seen it, it's sitting in the lobby of the Biomedical Innovations building. And again, this time, instead of using the plastic water bottles, we used our lab waste, right? Because a lot of us are medical researchers, right? And so we created this sculpture out of our single-use plastic, right? In the center there is viral plaque assays done from my lab and other viral labs here at Stanford. And we really are trying to draw attention to this crisis, but really the individual and collective roles that all of us have in tackling it, right? Because medicine and medical research, are responsible for at least 7% of greenhouse gas emissions in the US. And so, it's this horrible oxymoron, right? Because we're trying to heal our communities and heal people, but we're actually, in the long run, doing a lot of damage. So I encourage all the PIs out there who have labs, who are maybe watching online or sitting in this audience, to please consider conducting a waste audit in your lab, just to take a look at your consumption, to take a look at what your choices are and identify your usage patterns and maybe opportunities to improve things. And then again, collectively, we need to come together as a community to demand better alternatives for our planet. So to conclude, climate change has both direct and indirect impacts on infectious respiratory disease mediated by health inequities. The plastic pollution crisis provides a connection between respiratory disease and vector-borne disease in Kenya and elsewhere. The global plastic crisis has important health and environmental impacts that can include respiratory illness. And we're hoping that our nonprofit can tackle this problem through education, awareness, and active community engagement with both the local community and then also our policymakers and also the scientists. So new innovations and partners for plastic pollution solutions are definitely needed. And I welcome all of you to join us in this fight, because climate change is both our greatest health threat and our greatest opportunity. So thank you very much for your attention.